The two previous tutorials were on how to convert from a graph to turn it into the equation. Now we're going to look at how to start with an equation and turn it into a graph of a nonlinear inequality. So let's take, for example, the inequality y is less than 2x squared minus x minus 3. What's cool about this is that, maybe not cool, whatever. What's neat about this is that we're going to go through the same 5 steps, the same 5 questions that we've been asking all along with parabolas and quadratic equations in general. First, we're going to ask, are there any common terms that can be factored out between these 3, the trinomial over here? Nope, not in this case. Is there a negative a value? Nope, we have a positive 2. Third question, is this a special case? Is there a perfect square as the a value, a perfect square as the c value? Nope. 2 and negative 3 are not perfect squares. So therefore, we can see now if it's factorable. We determine if it's factorable by using a diamond factor. A times c goes up top, so we have negative 6x squared. Negative x, our b value, goes on the bottom of the diamond factor. And now we ask, okay, what are the factors? What are the ways we could get 6? We could do 1 times 6. We could do 2 times 3, and that's pretty much it. So then we ask, okay, are there any of these? Knowing that we have to do a positive times a negative to get a negative 6, are there any of these that are 1 apart from each other? Well, yes. Yes, they are. We then put in the 2x and the 3x and ask ourselves, well, one of them has to be negative. Which one is it? The negative 3, because we know that negative 3 plus 2 will give us a negative x as our sum on the bottom of the diamond factor. Alrighty, we take these 2 values and then we're going to plug them in to our generic rectangle. Again, we always put our a value in the bottom left corner, 2x squared, c value in the top right, negative 3. Again, looking over here, a value, c value. Then we put our 2 factors in as well. We got a 2x and a negative 3x in the diagonals. And let's see what they have in common with each other. I'm going to look at this first column first. 2x and 2x squared. Oh, they share a 2x. Negative 3 and negative 3x, they share a negative 3. Now let's look horizontally. 2x squared and negative 3x, they only share an x value, but no numbers. And 2x and a negative 3 looks like just the number 1, because no other larger numbers can go into them both. So then we're going to take these factors and we're going to rewrite them into factored form over here. 2x minus 3 and an x plus 1. We're going to move the rest of the symbols down. We have, and sorry, I should not have put that negative sign. That was really just a example number 1. So now we have y is less than these 2 factors. Why do we even bother factoring in the first place? Well, I'll tell you, it's first of all to help us find our x-intercepts when we go to graph this, but it makes it so much easier to plug in numbers. Instead of having to square them and then subtract by another x, all we're going to have to do in a couple minutes is plug in some numbers into this x spot and solve it out. It makes it really nice and easy. Alrighty, so now we're going to use that zero product property and we're going to figure out our x-intercepts. 2x minus 3, we set it equal to 0. X plus 1, set it equal to 0. And we're going to add 3 to both sides of this equation. Divide by 2. And our first root, or our first x-intercept, is x equals 3/2. Other side, or other equation, other factor, not as challenging. We're just going to subtract 1 and voila. There we go. We have our 2 x-intercepts. So what I might start doing now is creating my table of values. Anytime we have a graph, we know that we have to create a table of values that's going to be helpful to our plotting of points. So I would start maybe with -1, 0. I know that that's -1, 0 because I just solved for my x-intercept. And x-intercepts will always be the x has a number and the y is a 0 because it's located on the x-axis. And then I might plug in the number 0, 1, 3/2, and then maybe the number 2. I might even plug in the number -2. We'll just see how feisty we're feeling. We know that at 3/2, or 1.5, it's also going to be a 0 because, again, here are two x-intercepts located right up here to kind of give us a basis for, like, what numbers do we need to figure out around in order to graph this parabola? Well, let's go ahead and get started with some plugging in of the numbers. 0 is always a great option. Again, it not only gives us our y-intercept, but it's also just a really nice, easy number to plug into an equation, or an inequality in this case. So let's go ahead and start plugging in some numbers. We're again going to use this equation from right up here. I like to use the factored form to solve and figure out what my value is going to be. Now again, we're going to pretend like this inequality is an equal sign, because we're trying to figure out the coordinate that actually exists. So here we go. We have 2 times 0 minus 3 times the quantity of, instead of, again, x, we're putting in 0, plus 1. So we have 2 times 0, which is 0, minus 3, which is -3. 0 plus 1 is a positive 1. -3 times positive 1 is -3. So I'm going to write that over here, 0, -3. Let's go ahead and solve for the number 1. That'll be, again, fairly straightforward. Let's see, we got 2 times 1 minus 3 times 1 plus 1. I always keep my finger on the number I've just plugged in, just in case I forget halfway through. When I'm plugging in these other numbers and going back and forth, I always keep my finger on the number I've just plugged in. It helps, again, set me up for more success. Let's go ahead and simplify this down. 2 minus 3 is a -1 times 2, which is going to get us a -2. I would then do the same thing with the value for 2 and the value for -2, knowing, of course, that I need to have 5 coordinates in order to have a complete graph of a parabola. So let's see, what's that going to get us? Sweet. So again, you want to show work. I draw my arrows to, again, kind of apportion out my paper and demonstrate where exactly I've done all the work for each one. And that's just kind of how I roll to keep myself nice, neat, and organized. I highly recommend you doing it too. It'll help set you up for a lot of success. All right, so it looks like we're centering right around from -2 to +2. So I don't really need to go all that far on my x-axes, 1 and 2, and -1 and -2. Then I look at my y values. I pretty much just need to go down to, looks like -3-ish and about 7, so I might scale by 2s. Maybe 2, 4, 6, 8. Yeah, that looks good. Oh, sorry, and I got a little bit lazy and didn't write my numbers for my x-axis. So 2, 4, 6, 8. And then scaling by the same to go down on my y-axis, -2, -4, -6. So now I'm just going to plot these points that we have from over here. -2, 7, -1, 0, 0, -3, 1, -2, 3/2, so right about there, and then 2, 3. Now you might be thinking, this looks like a funky parabola. Well, that's because I know that halfway between my x-intercepts is going to be my vertex. So my vertex actually exists a little bit below. So what I might do is I might just sketch out what that parabola is going to be able to look like. Ooh, might even be a little bit higher than that. This is why we don't do math in pen, right? Something like that, yeah. And I would, of course, grab my whiteout. and I would undo my extra little thing down there. So you can see very clearly 1, 2, 3, 4, 5, 6. I actually have 6 coordinates for this one because one of my x-intercepts did turn out to be a fraction, and I wanted to have nice integer coordinates. So yeah, that's how we can turn, and I probably should have straightened this one out just a smidge. This is how we can go from an equation to factored form, taking that factored form to help find our x-intercepts to help guide where we want to plug in other numbers. It helps us determine, okay, what numbers are we going to use here? Using the factored form for other coordinates, and then actually generating a graph of those values, keeping in mind that we always know halfway between our x-intercepts will be located, is where we'll be locating our vertex. And sometimes we might not be given the vertex, but we still have to be able to figure out how to draw an approximate graph of this parabola, regardless of like all the specific information that we've been given. We can always mathematically solve it out to be an accurate representation of that work. Now, we aren't actually done yet though, right? Like, we have an inequality. This would be such a great graph if this was an equation, but it's not. This is an inequality, so we have to go back to the drawing board at the very end, and I'll tell you, this is what so many people make mistakes on. Okay, we have to still ask, is it going to be solid or dashed? And we still have to ask, is it above or below? And I've done a terrible thing in representing this by using pen. Oh, it's the worst. So what I would do is I would always have a super heavy, thick marker handy. Because in this case, if we look back to our original inequality, this is a less than sign, which means it's going to be dashed, which means I should not have connected my dots. So, if, in fact, you have made an error, no problem. You can either use whiteout, so one option is to use whiteout, and just white out every, couple of dashes so that you can create dashes. Another option is to do what I did, and have a really thick marker handy, and then you just draw on top of it, and you're golden. No one's the wiser. Alrighty, the second question though, so first we answered it's going to be dashed, then the second question is it above or below? We look back and we say, y is less than the parabola. Y is less than the x values. So therefore it's going to be below the parabola that we are going to sketch. And we have to make sure that we get all the components. Okay, don't just do the left side of the parabola. Don't just do the right side. You got to do all the underside of this parabola. And that is how we would actually finalize this answer in order to make it an inequality, that guy, instead of an equation with an equal sign.